Good morning, dear students. Welcome back to physics class. Today, I am going to present a new concept which is projectile motion. It is also one of most important parts from the chapter Motion in a Plane. In today's class, let us discuss on projectile motion. What are projectile and projectile motion? An object that becomes airborne after it is projected or thrown upward is projectile. The projectile is any object that is thrown into space upon which the only force acted is force of gravity. In other words, the primary force acting on the projectile is force of gravity, which does not mean that other forces do not act on it. From this point, you should mean that any object that is in flight after being thrown or projected is called a projectile. Examples are a football kicked up, a javelin thrown, etc. The object becomes airborne after it is thrown or projected. This kind of motion of the object is called projectile motion. The path followed by a projectile is known as a trajectory. Projectile motion is a two-dimensional motion, or it is the motion in a plane. In a projectile motion, there are two separate simultaneously occurring components of motion or two separate simultaneous independent rectilinear motions. One component is along a horizontal direction without any acceleration. That is, it will be having zero acceleration along the horizontal direction, which is along the x-axis. As it is not having the horizontal component of acceleration, it should have the horizontal component of uniform velocity directed along the x-axis. So, we can say that this uniform velocity is responsible for the horizontal or forward motion of the object. And second one is along the vertical direction with a constant acceleration due to the force of gravity. That is, it is acceleration due to gravity. It is along the y-axis. The uniform acceleration is responsible for the downward motion of the object. You should know that projectile motion is in the form of a parabola with mathematical equation y is equal to ax plus bx square. What are the accelerations in the horizontal projectile motion and vertical projectile motion of an object? Answer is, when an object is projected in air with some speed, the only force acting on it during its time in the air is the acceleration due to gravity. This acceleration acts vertically downward. There is no acceleration in the horizontal direction, which means that the velocity of the particle or the object in the horizontal direction remains constant. The remainder is projectile motion comprises of two parts. One is horizontal motion of no acceleration and second one is vertical motion of constant acceleration due to gravity. Look into the given slide. It shows the projectile motion of a vertically thrown up ball. The path traced by the ball or the trajectory is a parabolic path. Now, let us discuss on how to derive the equations of parabolic motion of projectiles. Let us consider an object projected at an angle theta 0 with respect to the horizontal axis with the initial velocity v0 are shown below. The point O is called the point of projection and theta 0 is the angle of projection. After the object has been projected, the acceleration acting on it is that due to the gravity which is directed vertically downwards. So, the acceleration vector A is equal to minus g j cap, which is the expression 1. Then, the magnitude of horizontal component of acceleration Ax is equal to 0, which is the expression 1a, and magnitude of vertical component of acceleration Ay is equal to minus g, which is the expression 1b. You know that V0 is the initial velocity of the projectile. Then, what are the components of this initial velocity V0? These are V0x is equal to V0 cos theta 0, which is the x component value of the initial velocity, and V0y is equal to V0 sin theta 0, which is the y component of the initial velocity V0. These are the expressions 2. Let us take the initial position to be the origin of the given frame of reference as shown in given figure. Then we have x0 is equal to 0 and y0 is equal to 0. You know the expressions of constant acceleration in a plane, which you had studied earlier. What are they? They are x is equal to x0 plus v0 xt plus half ax t square and y is equal to y0 plus v0 yt plus half ay t square. These are the expressions 3. When it encounters in projectile motion, the expressions 3 becomes as x is equal to v0 xt is equal to v0 cos theta 0 t and y is equal to v0 sin theta 0 t minus 1 by 2 gt square, which are the expressions 4, which represent the x and y coordinates of the position of a projectile at time t in terms of two parameters, which are initial speed v0 and projection angle theta 0. So, the expression 4 is the modified form of the expression 3 when we have considered x0 is equal to y0 is equal to 0 and ax is equal to 0 and ay is equal to minus g. By differentiating the expressions for with respect to the time t, we get the components of the velocity vector at the same time t. Therefore, in terms of components of the velocity vector v, vx is equal to v0x is equal to v0 cos theta 0 and vy is equal to v0 sin theta 0 minus gt or v0y minus gt. These are the expressions 5. Equal to v0x is equal to v0 cos theta 0, which is the expression 4a, and vy is equal to v0 sin theta 0 minus gt or v0y minus gt, which is the expression 5a. From these expressions, it is seen that one of the components of the velocity vector, that is x component, remains constant throughout the motion, but the y component changes, like an object in free fall in vertical direction. How can you understand this? You have to examine the expressions 4a and 5a. From the expression 4a, as v0 and theta 0 are constant, then the product of V0 and cos theta 0 is a constant. Thus, Vx is a constant. And from the expression 5a, t is changing. Thus, Vy is changed with respect to the time t. Thus, Vy is variable or it is not constant. Then, what should be the value of y component of the velocity vector of the projectile when it reaches the maximum height? At the point of maximum height, it will be equal to 0. That is, Vy is equal to 0. Then, you know that tan theta is equal to Vy by Vx. In this case, tan theta is equal to 0. Then theta is equal to tan inverse 0, which is equal to 0. Now, let us see how to form the equation of path of a projectile. You know that the shape of path followed by the projectile is parabolic. The verification is, we have the expressions x is equal to v0 xt, which is equal to v0 cos theta 0 into t, which is the expression for a. Y is equal to v0 sin theta 0 into t minus 1 by 2 gt square, which is the expression for b. As x is equal to v0 xt, then t is equal to x divided by v0 x is equal to x by v0 cos theta 0, which is from the expression for a. Then the value of t is substituted in the expression for b. We get y is equal to v0 sin theta 0 into x by v0 cos theta 0 minus 1 by 2 into g into x by v0 cos theta 0 whole square. Then y is equal to tan theta 0 into x minus g by 2 into v0 cos theta 0 whole square into s square, which is the expression 6. Since sin theta 0 by cos theta 0 is equal to tan theta 0. That is, this method shows that the expression 6 is obtained by eliminating the time between the expressions for x and y. The expressions are for a and for b. I'm going to read you the expression 6 again, which is y is equal to tan theta 0 x minus g by 2 v0 cos theta 0 whole square into s square is in the form of y is equal to ax plus b s square, where g theta 0 and v0 are constants, in which a and b are constants. This equation is the parabolic equation. So, the path traced by the projectile is a parabola. On next, you are going to see how to derive the expression for time of maximum height reached by the projectile. It is the time taken by the projectile to reach the maximum height. It is denoted by Ta or Tm. Since at this point Vy is equal to 0, then the expression 5a, which is Vy is equal to v0 sin theta 0 minus gt, becomes as Vy is equal to v0 sin theta 0 minus gtm, or Ta is equal to 0. So, v0 sin theta 0 minus gtm is equal to 0. Then tm is equal to v0 sin theta 0 by g, which is the expression 7. Then, what is time of flight of the projectile. It is the total time taken by the projectile to reach on the ground. It is denoted by Tf. The time Tf during which the projectile is in flight can be obtained by putting y is equal to 0 in the expression 4b, which is y is equal to v0 sin theta 0 t minus half gt square. So the expression becomes as y is equal to v0 sin theta 0 tf minus 1 by 2 g tf square is equal to 0. Then 1 by 2 g tf square is equal to v0 sin theta 0 tf. So tf is equal to 2v0 sin theta 0 by g, which is the expression 8. It is seen that Tf is equal to 2 Tm. It is 2 times the time of ascent or time of maximum height reached by the projectile. It is due to the symmetry of the parabolic path, as shown in given figure. Then, how can derive the maximum height reached by the projectile? Let us discuss on this. The maximum height reached by the projectile is represented by hm. It can be calculated by substituting t is equal to tm in the expression 4b, which is y is equal to v0 sin theta 0 t minus 1 by 2 gt square. Since tm is equal to v0 sin theta 0 whole divided by g, so the expression becomes as hm is equal to v0 sin theta 0 into v0 sin theta 0 by g minus 1 by 2 into g into v0 sin theta 0 by g the whole raised to 2 is equal to v0 square sin squared theta 0 by g minus 1 by 2 into v0 square into sin squared theta 0 by g is equal to v0 square sin squared theta 0 by g into 1 minus 1 by 2. Here v0 square sin squared theta 0 by g is the common, is equal to 1 by 2 into v0 square sin squared theta 0 by g is equal to v0 square sin squared theta 0 by 2g, or hm is equal to v0 sin theta 0 whole raised to 2 divided by 2g, which is the expression 9. And last, let us discuss how to derive the horizontal range of a projectile. The horizontal distance travelled by a projectile from its initial position x0 is equal to y0 is equal to 0 to the position where it passes y is equal to 0 during its fall is called the horizontal range, which is denoted by capital letter R. Since it is the distance travelled during the time of flight, Tf, the horizontal distance R is equal to v0 cos theta 0 into Tf. It is the product of the magnitude of horizontal component of the velocity vector and the time, which is time of flight, is equal to v0 cos theta 0 into 2v0 sin theta 0 by g is equal to v0 square by g into 2 sin theta 0 cos theta 0. So R is equal to v0 square by g sin 2 theta 0. Since sin 2 theta 0 is equal to 2 sin theta 0 cos theta 0, which is the expression 10. There is one question you have to answer. What is the maximum horizontal range of a projectile? We have the expression the horizontal range R is equal to v0 square by g sin 2 theta 0. R should be maximum when sin 2 theta 0 is maximum. It is possible if theta 0 is equal to 45 degree as sin 90 degree is equal to 1. So the maximum horizontal range R maximum is equal to V0 square by G. And it is possible when angle of projection is equal to 45 degree. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.